Welcome students. We are back with another lesson. Now in this lesson, fraction at spherical surface which we have discussed in our last class. So let us come to our question. Light from point source in air falls on a convex spherical glass surface where refractive index of the glass surface is 1.5, radius of curvature is 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. At what position the image is formed? So consider your glass surface, right? This is your glass surface. A light from the point source falls on a convex spherical glass surface. Now the glass surface has a refractive index of how much? 1.5. That means what is the refractive index of this glass surface? 1.5. So let's consider the glass surface as a refractive index equals mu2, and mu2 is how much? 1.5. Mu2 is how much? 1.5. Now they have not mentioned anything about the surrounding medium. So in such questions where they have not mentioned about the surrounding medium, you have to presume that the surrounding medium is air. The medium outside the glass surface is air. And if it is air, has a refractive index mu1, and the refractive index of air is always 1. Fine. So whenever they have not explained anything about or have not given any information about the surrounding medium, you will consider the surrounding medium as air, and the air has refractive index 1. So mu1 equals to 1. The next important point they have given is that the distance of the light source, the point from where the light is coming, okay, is how much? 100 centimeter. So let us consider a point, this point. Now at this point the ray starts to come. Now that this distance, the distance between your pole and your object, this distance, which is your object distance, and it is denoted by small u, is how much? It is 100 centimeter. Fine. The light travels from left to right, but my measured from P, from the pole to your object PO. So this will be positive or negative? Negative. So your object distance U equals to minus 100 centimeter. Fine. Now I have given is that the radius of curvature is how much? It is 20 centimeter. Fine. So if this is a convex, then in that case let us denote with C. Now the distance between the pole and the center of curvature, this distance is your radius of curvature. Fine. And how much they have given? R equals to 20 centimeter. Now it is measured from pole to the center of curvature, therefore it will be positive. So your radius of curvature is how much? 20 centimeter. Fine. 20 centimeter. Or you can also remember that the radius of curvature for a fine. Now is mu2 by v, the surrounding mu2 is the refractive index of the glass. Let me write somewhere here. Mu2. Okay, or I'll write here mu2 is the refractive index of this glass surface. Mu1 is the refractive index of the surrounding medium. U is your object distance. A light starts from this object distance. Light starts from this object. When it strikes the refracting surface, what happens? The light undergoes refraction and it bends towards the normal. So it forms an image at this point. This point is your I, and this distance is your image distance, which is denoted by V. Fine. And they have given this distance. This distance is your radius of curvature. Fine. Spherical surface mu2 by V, mu2 by V minus mu1 by U, mu1 by U equals to mu2 minus mu1 by R. Now I'll substitute the values here. Mu2 is how much? 1.5. Substitute 1.5. Mu1 is how much? 1. Substitute 1. Object distance U is how much? Minus 100 centimeter. If I put 100 minus 100 centimeter, minus and minus becomes plus. So I have plus 1 by 100 equals to mu2 is again 1.5, mu1 is 1, divide by radius of curvature is 20 centimeter. Fine. So 1.5 minus this one equals to 0.5, or which in turns equals to 1 by 2. Fine. So this is the numerator part, 1 by 2. Okay, 1.5 minus 1 is how much? 1 by 2. And in the denominator, what do you have? 20. Fine. So on simplification, this 2 will go to the denominator. So I will have 1 by 40. So this is written here. Fine. 1 by 40. Now using on further simplification, I can find my image distance V. Okay. So this part you can do it yourself to calculate your image distance. Now the image distance will come somewhere around to be 100 centimeter. So the image distance or the image will be formed at what distance? 100 centimeter. Now look, this is from left to right. So the image distance should be negative or positive? It should be positive. So make sure you get a positive 100 centimeter. Fine. So if your image is plus 100 centimeter, then the image form is at what distance? 100 centimeter from the glass surface, and it should be in the direction of the incident line. Fine. So if you have any confusion regarding this numerical, you can ask and I will re-explain it to you again. So that's it for today's class. Thank you.